In this section, we will talk about negative exponents. In general, in mathematics, we write bases using only positive exponents. So if your exponent is negative, for example, if your term is a to the negative n, this equals to 1 over a to the n, and 1 over a to the negative n equals to a to the n, given that n is a positive integer, and if a is a non-zero real number, that is a not equal to 0, since we cannot divide by 0. So remember that we need to always write our answers using only positive exponents. For example, express the following using positive exponents, and if possible, simplify. M to the negative fifth, by the definition of a negative exponent, equals to 1 divided by m to the fifth. In other words, if our exponent is negative, in order to rewrite this using a positive exponent, we must move the m to the negative fifth to the denominator, and it becomes m to the positive fifth. So m to the negative fifth equals to 1 over m to the fifth. 5 to the negative second will equal to 1 over 5 to the second power. Since we have a negative exponent, we move it to the denominator, so the exponent will become positive, and this will simplify to 1 over 25. Now with xy to the negative 1, be careful. This negative exponent, it only belongs to the base y. So we can separate this as x times y to the negative first. And y to the negative first is 1 over y to the positive first. So this equals to x times 1 over y. If we make the x into a fraction, this is x over 1 times 1 over y, which will give you x over y as the answer. So any negative exponent, rewrite that by writing 1 over m to the fifth, 1 over 5 squared, 1 over y, to write the exponent as a positive exponent. Simplify, write answers using only positive exponents. Let's multiply 3x to the negative 11th, y to the fifth, times negative 2x to the fourth, y to the negative third. First, let's multiply our integers and our like bases. So 3 times negative 2, that's negative 6. With the x's, we have x to the negative 11 plus 4. Remember, when you multiply the same base, we keep the base but add the powers. Then we also have y to the 5 plus negative 3, or 5 minus 3. This will simplify to negative 6x to the negative 11 plus 4 is negative 7. 5 minus 3 is 2. So this is 6, negative 6, x to the negative 7th, y squared. Now we cannot leave negative exponents in our answer because we read our answers using only positive exponents. So the only base with a negative exponent is the x to the negative 7th. So we will rewrite this as negative 6 times 1 over x to the 7th times y squared, which will equal to negative 6. That's on the numerator. Now, even though the 6 is negative, the exponent for the 6 is a 1, which is positive. So we keep the negative 6 where it's at. The x to the negative 7th moves to the denominator and becomes positive, since the exponent for the base x is a negative. Y has a positive exponent, so y squared will stay on the numerator, and x to the 7th will move to the denominator. Here's another example. Let's take 4a to the negative third, b to the negative second to the third power. The product to power rule says if you have a product all raised to a power, then we take each individual term and raise it to that power. So we take 4 to the third power times a to the negative third to the third power times b to the negative second to the third power. Okay, now 4 to the third power is 4 times 4 times 4, which is 64. When you have a power to a power, you multiply the two powers. That gives you a to the negative 9th. Again, we have a power to a power, so you multiply the powers. That gives you b to the negative 4th. Remember to use parentheses every time you separate these terms as 3 separate ones. This gives you 64. A to the negative 9th is 1 over a to the 9th. B to the negative 4th is 1 over b to the 4th. Okay, this equals to 64 on the numerator. On the denominator, we have a to the 9th and b to the 4th. So 64 a to the 9th, b to the 4th. We will do part C in class. Next, let's divide and simplify. Write answers using only positive exponents. Okay, first let's separate these. We have 6 over 2 times x to the negative third over x to the fourth times y to the fifth over y to the negative third. Okay, so the quotient rule of exponents says, well, 6 and 2, we just divide that, that's 3. The quotient rule of exponents says if you have a to the m over a to the n, this equals to a to the m minus n, which means you always subtract the exponent of the numerator minus the exponent of the denominator, and the result will remain on the numerator. So for x to the negative third over x to the fourth, this will equal to x to the negative 3 minus 4. With y to the fifth over y to the negative third, this will be y to the 5 minus negative 3. Now the reason we get two negatives here is because one negative is from the rule, and the second negative is because the 3 is negative. So we have 5 minus negative 3. To simplify this, we have 3 times x to the negative 7th. We got two negatives in a row. These become positives. So we have y to the 5 plus 3, which is going to be 8. Now we can only write answers using positive exponents. So the x to the negative 7th needs to be rewritten as 1 over x to the 7th. Y to the 8th has a positive exponent, so we're going to write that exactly the way it is. So on the numerator, we have a 3, we have a y to the 8th, and on the denominator, we have x to the 7th, which will be our answer.